This video covers topic 19.7 over operations with radicals. All of your operations, adding, subtracting, multiplying, and dividing, have been listed here for the steps. Remember that there are times when you need to simplify either at the beginning or your answers or somewhere in there, and those steps for simplifying have not been listed, but all of these, adding, subtracting, multiplying, and dividing, are ways to simplify. So, problem 1, when I look at this, there's no adding, there's no subtracting, there's no multiplying, there's no dividing, which means I simply need to see what I can do with this square root. So I have 5 times the square root of 144. The square root of 144 is 12. Works out nicely. All you have to do is plug it into the calculator or look at your perfect squares chart. So 5 times 12, 12 was what I simplified. So I replaced the square root of 144 with 12. 5 times 12 is 60, and I'm done with that problem. Problem 2 is another simplifying problem. The square root of 49 is 7. The square root of 144, as we just said, is 12. So I have a 4 out front times 7 over 12 because I've simplified the square root of both of those. When I multiply, 4 times 7 is 28. 28 divided by 12 simplifies. Or you can say 4 and 12 simplify into 3. You can also plug this into your calculator. 4 times 7 over 12 is the same thing as 7 over 3. Problem 3 is just asking me to simplify. 72 can be broken up into 8 times 9. 8 is 2 times 4. 4 is 2 times 2. 9 is 3 times 3. So I have 2, 2, 2, 3, 3. Pairs come out, so 2 and 3 come out to make 6. And then this 2 is stuck under the house. There was nothing else in the front that I need to bring into effect. And so my simplified answer is 6 square roots of 2. And remember, all of these, you can take the beginning and multiply the beginning and plug it into your calculator, the end, plug it into your calculator, and make sure that they compare with the decimals. Okay. When simplifying things with letters, the first thing I'm going to do is make sure that this does not simplify nicely. So 392 does not. So 392 divided by 2 is 196. Now I believe 196 is a perfect square root, and it is 14 and 14. So 14 will go outside of the square root. 2 stays inside by itself. And then when we have letters, we divide those exponents by 2. So 4 divided by 2 is 2. Remember, even numbers come out of the square root evenly. So I have a 14 out front and a b squared out front, and then a square root of 2, and that's the only thing left in the square root. Problem 5, still simplifying, so I'm going to simplify numbers and then letters separately. So with my number, 150 can be broken up into 10 and 15. 10 is 2 and 5. 15 is 5 and 3. So I have 2, 3, 5, and 5. So the 5 will come outside. The 2 and 3 stay inside the square root to be 6. With letters, you take your exponent divided by 2. So 3 divided by 2 is 1.5. So 1 goes outside. 0.5 means I have 1 that stays inside. And then E, 4 divided by 2 is 2. And they will both go outside nicely. So my final answer is a 5 outside, a C outside, and an E 2 outside. And then inside the square root, I have a 6 and a c. Problem 6 has already been done for us. Remember, when we add or subtract, you have to simplify if at all possible. Square root of 3, square root of 3, square root of 6, and square root of 3 cannot be simplified. So once I've simplified if possible, I then combine my like terms. So I have 5 square roots of 3, adding 7 square roots of 3, taking away 2 square roots of 3. So 5 plus 7 minus 2 is 10 square roots of 3. And then the 4 square roots of 6 had nothing to change it, so it just gets rewritten at the end. So 10 square roots of 3 plus 4 square roots of 6 is my answer. Remember that if you get an ugly decimal, you cannot write the decimal as your answer. You must simplify. So with problem 7, I have a square root of 10. 10 is 2 and 5 and cannot be broken down any further. So I'm going to just rewrite that. 40 can be broken down into 4 and 10. 4 is 2 and 2. 10 is 2 and 5. So I have a pair of 2's that will go outside. So negative 3 and then 2 square roots of 10 because of the 2 and the 5 that are left. Negative 3 times 2 is negative 6 square roots of 10. And then 4 square roots of 5 stays in the back. Can't reduce the square root of 5. Now to reduce, I have 10 square roots of 2 minus 6 square roots of 10. 2 square roots of 10 minus 6 square roots of 10. 2 minus 6 is negative 4 square roots of 10. And then the 4 square roots of 5 has nothing else to change it, so it simply gets rewritten. When we multiply, outside stays with outside, inside multiplies with inside. So the negative stays out front. 6 times 15 gets rewritten inside. So on my calculator, 6 times 15 is 90. So 90 can be broken up into 9 and 10. 9 is 3 and 3. 10 is 2 and 5. So I had that negative out front. A pair of 3's are going to come outside. 2 and 5 stay inside to make 10. So negative times 3 is negative 3 square roots of 10. Problem 9, we're dividing. So because I have 90 and 5 both inside the square root, I can divide because they're both inside. So 90 divided by 5 is 18, still in the square root because I've done nothing to change them. Now the square root of 18 can be broken up into 3 and 6. 6 can be broken up into 2 and 3. So I have a pair of 3's going outside and a 2 staying inside. Remember, once I've divided, I don't have anything inside the denominator that's a square root, so I'm good on that one. And problem 10, 1 and 2 are both inside the square root, but 1 divided by 2 is just 1 divided by 2. I can't simplify it. I can try to break it up, the square root of 1 and the square root of 2. The square root of 1 is 1, but I still have that square root of 2 in the bottom, so this is where I have to rationalize. That means I take the denominator, multiply it on the top and the bottom. On the top, 1 times the square root of 2 is the square root of 2. On the bottom, square root of 2 times the square root of 2 is just 2 with no square root. And I can stop here because there's nothing else I can simplify, but there is no square root in the bottom. Remember, with all of these problems, you can do a quick check in your calculator. by typing in what you originally had. For example, let's do problem 8. I originally had negative square root of 6 times the square root of 10. I'm sorry, 15. And I simplified it to negative 3 square roots of 10. And I have the same starting decimal and the same ending decimal. So for all of these problems, I didn't do it because all you need to do is be refreshed on how to do these by hand. But for every single one, you can type in the original, type in your answer, and make sure that they all have the same decimal. You cannot write your decimal as your answer, but you can use it to confirm that you have the right answer because they are the same.